Okay, here we are on the pre-lab, and I've got a note to self here. I got to make a note to myself. I'm going to do the lab portion. I'm going to do the lab on this on Monday. Um, all right, so you got that to look forward to. Um, so anyway, let's just take a look. I want to make sure this is not due September 19th. I've got to. Of course, I'm going to modify this. In fact, today is February 9th, so we'll make it due February 16th, a week from today. So you got a chance to look at it, and then the lab will be due a week after that. All right. We'll begin today. Okay. So what's the SI unit for measuring force? That's in the thing. In physics, we define the force as, how do we define that? Okay, the acceleration on the Earth's surface due to gravity, which one of those? And this is in SI units. Okay, by the way, we know this isn't right, but that's the mass of the Earth. Just to let you know. In physics, we define work as, that's a trick question. Be careful with that one. If I raise a 5 kilogram object 4 meters in the air, how much work did I do? Remember, don't forget the gravity part. Okay? Don't forget the gravity part. All right. The SI unit for mechanical work. Okay, I added the phrase mechanical to make it physics correct. All right, to be in because there's other kinds of work. So mechanical work is, what do we use? Puppy monkey baby. I forgot where that came from. That was a couple years ago. I don't know what the words. It's some kind that puppy monkey baby is an alternative fact. Okay. All right. In physics, we define power as. Okay. I made this up 2 years ago, and now it's there. Here it is. All right. Anyway, the SI unit for power is. What the hell is a? Okay, if I raise in 1 point, okay, so how much power did I do? We're almost done. If I weigh 220, what is my mass in kilograms? The conversion factor for pounds to kilo. In other words, you multiply those two numbers together. All right? This and this, because that's how you convert it. All right? Don't believe me? And so if the rise on a stair step is 18 centimeters and the run, okay, I've got to work this out so that you all can see this and figure this out. Okay, so here's what we do on questions 10, 11, and 12. So I got to make sure that we're doing this. All right. So my weight, because you're going to weigh yourself, or if you want to get somebody else to do this for you, or you can make up your weight. It's not like, 229 pounds. My weight's 220. I'm lying. I am lying like a rug. All right. Conversion. I got to write down what the conversion is. Then I'll let you in on my secret of what I'm doing over here on this sheet of paper. 0.53592. All right. Wow, this upload is taking forever. This one thing. Okay, we're almost there. We're almost there. It's driving me nuts. All right. Anyway, usually it uploads really fast. So let's take a look at what in the rise. (18 centimeters), and the run is equal to 30 centimeters. Okay, here's the equation for kinetic energy, and I think that's where we end. All right, so now let's take a look at this. Let's go back real quick. Sorry. Okay, if I weigh, what's my mass in kilograms? So my mass is 229 pounds, times 0.453592 pounds, or kilograms per pound. So the pounds cancel, and you just multiply those two numbers together. So you get 229 times 0.453592, and I get 103.8. I'm just going to go ahead and say I'm 104 kilograms, which I'm lying, but that's okay. I think this is when I dropped about 20 pounds, so I got my fancy uniform for my daughter's wedding. Anyway, so if the rise of a stair step is 18 centimeters and the run is 30 centimeters, the run being where you put your foot, what is the diagonal distance from the tip of the run to the top of the rise in centimeters? Okay, you might be going, why are we doing this? Because it comes up later in the lab. Okay, so how do I coordinate? All right, so here's what we're going to do. So 18 by 30. All right, and I'm going to, and then I'm going to convert it to meters for you. Okay, so if the rise is 18 centimeters, and this is a 90-degree angle, the run is 30 centimeters. Okay, we're not going to compute the angle. I just need to compute this distance. That's a right triangle. You remember, don't you? 18 squared plus 30 squared. Take the two of those together. Now my calculator, I'm going to show off here, does it all in one step. I can just do 18 squared plus 30 squared, close the parentheses, boom, and do it all one step and get 34.9 or about 35 centimeters. If your calculator does not do it in one step, if you have just a very simple at-home calculator that you got from the bank or something, you go 18 times 18 plus 30 times 30. So you get 1224. Then take the square root, hit your little square root button. My calculator doesn't do it that way, but you would just hit the square root. So I go to the second answer, boom. And there it is, 34, same thing, 35 centimeters. All right, and then that in meters is 35 centimeters divided by 100 centimeters per meter. So the meter comes up here, the centimeters cancel, 0.35 meters. Or just move the decimal over 2. Okay, that should get you through the pre-lab, and that's due in a week.